Hi everyone, welcome to another design programming tutorial. My name is Brittany. Today we are working on simple algorithmic design. It is quite challenging compared to the past two, so I really advise you guys to pay attention and stay focused and we'll get through it together. Cool, let's get started.
To start off today's tutorial, we'll be talking about the random function. What is random, you may ask? Well, the random function returns to us random numbers anywhere between a defined range. For example, 0 to 255, 100 to 300, and so on and so on. This can be helpful when we need to randomize numbers for a particular purpose, such as coordinates or colors and sizing of an ellipse or a rectangle. So, how might we use the random function? Well, the random function accepts either one or two arguments. If one argument is given, then the function returns a random number from 0 up to, but not including, the number that you have made your argument with. If two arguments are given, the function returns a number from the first argument up to, but not including, the second argument. The key takeaway for the random function syntax is the first value is inclusive, meaning it is included, and the second argument is exclusive, meaning it's not included. Let me show you an example of how this all works. Let's just say I want to recreate that GIF that we saw on the first lecture slide. So the first thing I'm going to do is type in my setup function. Then I am going to create my canvas. And I'm just going to want to make it a small screen, so maybe 400 by 400 will be fine. We'll have a look and see. And I just want to give it maybe a light grey colour. Note that I am putting the background color in the setup function because we want those circles to overlap each other and to be all on the one page. But so if we put the background in the draw function, it will keep flashing and writing over all the circles, so you only have one circle on at a time. So let's just see if that's big enough. Yeah, that's pretty good size. So now I also want to just adjust my frame rate to make the draw function come a little bit slower than what it normally is, and I'm just going to change that to 5. And okay, so now I'm going to move on to my draw function. And now I'm going to make two variables that are just for the draw function, okay? So I'm going to call the first one random x. And what I want to do is for these two variables is I want to specify where the circles are being drawn to. So I don't want them drawn all over the canvas. I want them to have a nice even margin. So what I'm going to do is set the random values to which these circles can be drawn to 100, and then to make that margin I want width minus 100. So it comes into around here-ish. So that's sort of where the margin would be. Same thing for another variable, so let random y equals random 100, and then height minus 100. So I want the margin then to be there. So it's a really even square of where the circles can be placed. So now I want to set my circle color. So what I'm going to do is use the fill function. And then I want to set each RGB value to a random value. So to do that, because we are using ranges in the random function, I just want to set it to 0 to, which is black, to 255, which is white, okay? And then I just want to repeat that for each RGB value. So you should get a random color for each. Another thing I want to also do is set an opacity, so using the alpha value of the fill function, and I just want to set that to around 200. Okay. And then I'm just trying to envision what it might look like before pressing run, and I don't really want a stroke. So I'm just going to automatically get rid of that stroke, and if it looks bad, we can change it later. So now it's time to draw my ellipse. So I'm going to draw the ellipse, and I'm going to use these variables that we have made to determine where they go. So I'm going to use random x and random y, and then I'm going to set the size to 100. Cool, that should be working. Let's have a look. Oh, there's an error. Oh, I know my error. There we go. Make sure you're always debugging. But see how now all the circles are going into that margin specified by width and height minus 100. And it's all the circles are on the one page because the background is in the start function. And there's also a low opacity because we set it to 200. Cool, awesome. So now that I've shown you an example of how to use the random function, we're going to start working with the Introduction to Random challenge. Make sure you have this open and working along, because I'm only going to do step 1 and then you guys are going to have a go at doing the rest. So for step 1, we want to make random lines appear. Okay, we want them to be at different positions, different lengths and different colors. So we have quite a bit of scaffolding code, and the first thing I want to do is change the background color, maybe to something like 240, just to make it like a light gray. And then what I need to do now is make the line and the stroke random values. So similar to that example, all I want to do is make it random to every color. If you wanted to, you could limit the values of the random function. So if you want a certain type of red, green, or blue, you could limit those. But for the time being, I'm just going to open it wide up. The next thing I want to do is make the line random. Now, there's plenty of other ways to do this, but I think the easiest way for today is just to go random render width. So the whole of the canvas is going to be able to draw lines on, and then random height, and then I'm just going to copy this over, and that should all work. Let's run it and see how we go. Yeah, cool. So that's working perfectly. So now what I want you to do is have a go at step 2 and 3 by yourself. They are a bit more challenging. They use 4 loops from last week, so make sure you are asking your tutor for guidance if you need help. Pause here to complete the task. Let's move on to our second section of today, noise. So, what is noise? Typically referred to as Perlin noise, the noise function provides an output which changes randomly in a smooth and natural way. How is this different to the random function, you may ask? Well, as you would have seen in the past challenge, sometimes the random function can be a bit too random. There may be times when you want to create random movements that are more natural and more smooth. The noise function returns a random value based on the Perlin noise. When you call the noise function, it generates a naturally ordered sequence of random numbers. Another way to think of the difference between noise and random is that the random function selects purely random numbers with no relation to the previous selected value, whereas the noise function generates value that produces a more harmonic sequence of numbers. Let's take a closer look at the syntax of the noise function. The number returned when you call the noise function is always between 0 and 1. The x value specifies the x coordinate in the noise space, and the y value specifies the y coordinate in the noise space. The noise function can't be called without at least one argument. Therefore, the x coordinate is always needed. Let me show you an example of this. So just like the random example, I'm going to recreate that GIF on the tutorial slides. So the first thing I have already done is I have made my canvas size, window width, and window height. But the next thing I want to do is make a global variable. So I'm going to call this variable counter, and for the time being, I'm going to let counter equal to 0. And we'll use that pretty soon. I'm going to again put my background in the setup function, and I'm going to change it to like a really like white bluey color, okay? And then what I want to do is I want to make another variable specific to the draw function, and I'm going to call that noise value. Okay, so this is where we start using the noise function. So I want to let noise value equal noise. But remember back to the tutorial slides how noise has to at least take one argument or one parameter, and that's always going to be the x value. So for this case, I want noise equal to the counter that we have already declared as a global variable. And that's going to produce a number or return a number between 0 and 1. So I want it to be not just between 0 and 1, so I want to multiply that. So whatever number is produced, I want to multiply that by the width, and that will give it its side-to-side effect that you see in the GIF, okay? So then I'm just going to set my stroke to a green color, I think. And then I'm going to draw my ellipse. So I want the x position of my ellipse to be the noise value that we have made. So that's where it's going to be located on the x-axis. And then I want the y value to be in the middle, so height divided by 2. And then I want the size of the ellipse to be pretty small. I want to set it to 50. And now I need to update my counter, right? So I need to update my counter so each time the draw loop is run, the counter function is updated and the circle keeps on moving. So counter, I don't want to update it by much. I just want to increase it a tiny bit. So I'm going to go counter equals counter and really small 0.05. So it's at least still updating and changing, even though it's really small. So if I run this, I'm probably going to get an error. It's because I put brackets in. There we go. Now we go. We see how now it's moving. And it's going to slowly make its way all across the screen eventually. I know this is a really confusing concept to understand, okay? So make sure that you're asking your tutor if you're really confused. So now we're going to have a go at the Introduction to Noise Function challenge. So this challenge is not so much step-by-step guide, it's more about exploring and having a look at the noise function itself. So I'm going to go through step 1, and then in step 2, you are going to be working in groups and seeing how the noise function actually works in relation to for loops and mapping, just like we learnt last week, okay? But for now, let's just go through step 1. So this is my original code that was given to us, and if I run it, you can see that the line is moving across the screen at like a moderate pace. It's not too fast, it's not too slow. And that's because in the noise function itself, the argument is a noise step variable, which is, before the noise function is even called, incrementing by 0.01. So it's at the slowest pretty much it can be other than 0. So if I want to make that faster, I can change that to 0.05. See how it's sort of getting more crazy and a little bit more faster. If I want to further increase, go 0.09, and it's become really erratic, really fast. There's not a lot of structure to it, etc. So what this n variable is doing is it's calling the noise function, and the argument is the noise step variable. So at the moment it's 0.09, and it's timesing that by the width. Remember in our previous example that when we times it by the width, it lets the program know that it wants to use the whole width of the screen. So that's what makes the lines go all the way across the screen. Okay? So should I just run that again to let you have a look? There we go. So now for part 2, I want you guys to have a go at seeing if you can recreate these 8 images. It is a big step up, so your tutor is going to be there to guide you, but this is going to be the group activity for the week. So make sure you are in groups of 2 or 3 and working through this together. Have a look at your for loops, your nested for loops, and potentially your mapping function from last week. If you're still a bit confused on all those, we can do a quick, your tutor can do a quick run through again. But essentially you want to try and recreate all these images. One of them is done for you. So have a go and see about changing the variables, maybe of the noise scale, trying to adjust the noise val variable and see what you can come up with. If you've done all of that, it might be a really good idea to see if you can have a go at changing the color or the grayscale effect. Cool. Good luck, guys. Pause here to complete the task. Now for our final section of today's tutorial, easing. Easing is the smoothing of a transition between 2 values and can provide structure to your randomly generated values. It allows for animations to move more naturally and realistic. In p5.js, we use the Lerp function. The Lerp function is used to find a number between 2 numbers. Lerp calculates a number between 2 numbers at a specific increment. The amped parameter is the amount to interpolate between the 2 values, where 0.0 equals to the first point, 0.1 is very near the first point, 0.5 is halfway, and so on and so on. Just like random and noise, let me show you an example. So, making the Giphy example from the tutorial slides, the first thing I'm going to do is make 2 variables, x and y, and I'm going to let them equal to 0. So in my setup function, I am just going to quickly set up a no stroke rule. This will help us later on. And then, so in the draw function is where the magic happens. So I am going to change the x and y values to using the lerp function. So I'm going to make lerp, the first value of lerp be x, the second value of lerp be the x position of the mouse at any given point, and then 0.05. Okay, I'm going to do this same thing for y. I'm just going to quickly change the variables. And the reason I am doing this is, remember, so when you have the lerp function, this third value interpolates between the first 2 values. So what I'm meaning by making the amped value 0.05 is that I am moving 5% from the x value, and I'm moving 5% to the position of the x position of mouse or the y position of the mouse each frame. okay? So I'm just going to repeat that. When I have 0.05 here, it means that I am moving 5% of the way each frame between the X position and the X position of the mouse, okay? Same thing if I was to change this to 0.1, that is now moving 10% of the way, okay? So that's how I'm using Lerp. And now I just want to fill and add a stroke. And now I want to draw my ellipse. So I want the ellipse to follow my mouse. Okay, that's the whole point, and I want it to ease and make it smooth and make it natural. So I'm going to do the position of the ellipse to be X and Y, which is now the Lerp function, and I'm just going to make the size of the ellipse just 50, okay? And that should be pretty much it. Yeah, so if I have that now if I put my mouse onto the canvas, it's going to follow me. But if you can see how it's like sliding quite naturally, if I adjust these values, say I want now 50% of the way, and run it, see how it's not as smooth, it's not gliding. So if I now go, say, 20% of the way, it's a little bit more smooth, not as, I think it's a bit more smoother than the 0.05. And if I go 10% of the way, yeah, that's quite nice. Cool.
So now it's your turn to have a go at the Introduction to Easing challenge by yourself. I understand that this might be going a bit over time. So if you have some free time, I would strongly encourage you guys to work on this at home, or better yet, in class. Make sure you are asking your tutors questions on Slack about using the coding help channel and the general channel before you DM your tutors. Cool. Have a good week, guys, and we will see you next week.